I want to talk to you today about calculating standard cell potential. So the equation that you see is the equation that most students wind up with. This is the equation that's in your textbook. This is the equation that's in ALEKS. So this is the standard cell potential of the entire cell. You put the two half cells together is the standard potential from the cathode minus the standard potential of the anode. Now the part that this doesn't say is that both of these are actually going to be your standard reduction potentials. So both of the numbers from the previous equation come straight off of the table that we're using. So the whole reason why you have that minus sign in there is because you're taking into account that one of them is the reduction and one of them is the oxidation. But oftentimes the way it's memorized is cathode minus anode. But the part that's not mentioned is that both of those come off of the exact same table, which is the standard reduction table. Now, with the standard reduction table, this is the table that's given in your book and in the notes, and you can always orient yourself by looking at the top and the bottom, and what you should see is you should see fluorine at the very top, which is much more likely to be reduced. Fluorine's always looking for extra electrons. That's why it's the most electronegative element. And down at the bottom, you can see lithium. Lithium is always willing to give up electrons or always ready to be oxidized. Now, there's a different equation that looks very similar but is distinctly different, which looks like this. So now we have still the same idea, the standard cell potential, but now we're looking at it's the standard reduction potential plus the standard oxidation potential. So now that minus sign has gone away, except it really hasn't. Realize that what's happening here is the table is given in reductions. Everything in the table is a standard reduction. If you were to calculate the standard oxidation potential, it would have the opposite sign. You would flip the reaction around, and as you flip the reaction around, you would flip the sign. So if you're looking at the standard reduction potential plus the standard oxidation potential, this is assuming that you're going to flip the sign of whatever's at the anode. If you take a look back at both equations, you'll find they actually do the exact same thing, which is take into account that whatever is happening at the anode, whatever is being oxidized, actually will have a reversed sign from the way you see it on the table, since the table is all about reductions.